Hello, everyone. Welcome to another episode of Squaring the Circle. In this episode, I'd like to talk a little bit about Stonehenge, the famous monument on the Salisbury Plain in southern England. I think most everybody knows about the existence of Stonehenge, and there's been some very interesting speculation around what its purpose and meaning is. And what I'd like to do is look at it in the light of some new evidence that has emerged within the last year, and that has to do with the lithology of the monument. By that, I mean the rock types, the type of rocks. So we basically have three types of rocks. We have a sandstone rock, which forms the outer large stones that are called the Sarsen stones, which we're going to look at in a second. Inside there, we have another type of rock. It's called a bluestone, and they have different lithologies. And then there's a third type of rock that forms the altar stone, and it's a third type of rock. And then once you have the lithology of rocks, you can then, or hopefully, if you have enough data available, you can determine the provenance of the rocks, which is where they came from. What part of a larger rock mass are they derivatives of? So lithology, you identify the rock type, and then the provenance, you can identify where is that rock type found in the earth, right? So for many years, the bluestones, and it's still believed that they came from Wales. And this is, I think, about a 125-mile transport distance, something like that. 125 miles from Wales, and it was believed that the Sarsen stones came from relatively nearby quarry, maybe within 30 miles away. But it was believed that the bluestones from Wales were transported the farthest distance. Well, over the last few years, doubts have crept in as to whether or not the lithology of the altar stone is the same as that of the bluestones that form the bluestone circle and the bluestone horseshoe. Well, more in-depth studies showed that it was indeed different. So we're going to talk about that, and plus some of the other factors associated with Stonehenge, some of its attributes, and then see if we might surmise that there could be some implications as far as the meaning and purpose and function of Stonehenge. So I think we'll just get right down into a slideshow here where we can start getting some images and see what we're talking about. And this is the monument, the full moon rising in the distance. And we're going to go through some of this here. And here's the larger context of the structure. Now, you can see it's in pretty rough shape. It's gone deteriorated much. There are stones that are missing, probably hauled off and used for other purposes. But there's enough of the stones left to reconstruct the original monument to pretty darn close. I mean, literally to within a few inches almost. Because anytime you have the arc of a circle, you can use simple geometric processes and get the center of that arc, right? And then once you have the center of that arc, then you can recreate the entire circle. Okay, so this is the Stonehenge from the air. Now, a couple of things I want to call your attention to here is that you've got this moat around here, what was once a moat, the ditch, and a bank. Now, we're not going to talk about those in this episode, but we will talk about those in future episodes. But that is part of the much larger structure here. It was probably the first thing that appeared on the site. But the point is that Stonehenge is much more than just the circular stones that you see here. It also included major earthworks, in this case, ditch and a bank. Okay, let's take a little closer look at the sarsen stone ring. This is the outer ring. You've got the uprights, the sarsen stone uprights, as they're called, and then you've got these lintels. So at one time there were 30 of these, and they formed a complete ring, and the lintel stones on the top then formed a capstone, if you will. So with the 30 uprights and 30 lintels. And you can see through, when you look through the aperture here, you can see one of these so-called horseshoe trilithons, which if I go back, you'll see those are the big ones here towards the center of the monument, and the sarsen stones are the outer ring. Okay. And here's just another view of the sarsen stone uprights and the capstones or the lintels. Okay. Now here's basic ground plan of the monument. And for the bluestone ring, I've just superimposed, a blue circle. And for the sarsen stone ring, I've superimposed a red circle. Now, the black stones are the ones that are remaining, and the hollow or the white interiored ones are missing. One of the interesting things here is the summer solstice sunrise axis, which leads to the position of the sun when it's at its farthest north position at summer solstice on the horizon, at its rising point. I'm not showing it here. You don't see it in the ground plan here, but there's another upright stone out here in the field called the heel stone that marks that position very accurately. Right here you see is the altar stone, and the altar stone may have fallen over. I'm not sure. It's got a couple of other large rocks more or less on top of it, so it's difficult to discern its exact position. I have a nice little model here, a 3D model, to help visualize the layout of Stonehenge in a reconstructed form. So you can see we've got the sarsen stones, which are a sandstone rock, basically, forming the horseshoe trilithons. There were 5 of those. You've got the bluestone horseshoe inside, which is not a complete circle. It's not a closed circle. However, the arc is tangent to a circle, and that circle is right at roughly 39.5 feet, possibly a little bit more. You got the bluestone circle here on the outside. The just inside the sarsen stone. You've got the blue stones. And there's debate about how many of those there were. I think I've seen 56 and I've seen 60 being generally the numbers that are usually invoked. And interestingly, both those numbers have significance. Now, the alignment is directly along that solstitial axis that you see here. And in the assumed reassembly of the monument, you would have had an opening all the way through here, marking that line on the summer solstice where the sun would be rising. Should go this way, okay, like this. So I hope that kind of gives you the picture, the general picture of it. You can see here that the lintel stones are mortised and tenon together like this. And we know that because we've seen that in the remaining ones. We actually see this mortise and tenon effect, this tongue and groove effect here that you see recreated in the model. Okay, let's see if we can navigate our way back to our PowerPoint. And there we are. So here's some dimensions. The sarsen stone circle, the center line of the stone is 100.8 feet. Now, as far as these dimensions go, obviously there's going to be some variability in these. These dimensions that I've got here have taken from the 3 separate surveys of the monument that I was able to access. Okay. Now, they've all varied slightly. What I was doing, though, was an attempt to reconstruct the original, okay? And if you do this and you use these dimensions here, you will come up with a template, which if you used to actually attempt to build a a reconstructed duplicate of the model, you would come up with one that would be so close to the speculated model here that for all practical purposes, you could almost consider them to be identical, right? But again, you know, you can quibble over a few inches here or a few inches there. I think, though, that the accuracy of what's here is enough to reconstruct the original geometric template. And I think we can safely conclude, or at least surmise, that there was an exercise in geometry going on here, that there was a template of geometry rather than just randomly laying it out. We know, and it has been known for a long time, that there is this significant astronomical alignment. So we know that the orientation of the model, of the structure, was not just randomly placed. You had to have this all-important alignment, this axis to begin with. Once you've got that, it would only make sense that you would then use a very rational and specific sequence of steps to determine the distances and proportions and ratios of the rest of the monument that's now going to be juxtaposed onto that solstitial alignment, if that makes sense. So what we have here in these dimensions is we have dimensions that are very, very close, and several of them will give us indications that we are on the right track, because it turns out that the average distance of the center line of the stones, which is marked by the average length of the lintels, is 10.56 feet, right? Now, there's enough of them that remain, and the tooling of them is highly accurate. So from that, one comes up with a number that's very close to 10.56 feet, which would also represent the center line of the sarsen stone uprights. Well, if you measure on the sarsen stone circle, the outer face, it works out to be very close to 105.6 feet. Now, this suggests something, right? It suggests that there's a common unit of measurement here being involved, that you've got 10.56 feet for the average length of the separation of the sarsen stone lintels, and you've got 105.6 feet, give or take a few inches, being the diameter of the outer face, right? Now, those numbers to me are very interesting, and here's the reason why. If you put 105.6 into a calculator, and then you multiply that by 50, you've got exactly our modern mile, 5,280 feet. Now, if you have the average length of the sarsen stone lintels, and you multiply that by 500, you get, again, the length of our modern mile, 5,280 feet. Now, does that suggest the possibility that there was a unified system of measurement here that was based upon what's still extant as the modern imperial mile and submultiples of that unit, or multiples that started out, let's say, at 10.56 feet? Maybe that was the fundamental unit. 10 of those then gave the outer face of the sarsen stone circle, and then 500 of those fundamental units gave the mile, which it turns out happens to be very, very close to 1,000 paces of an individual counting out paces who is just perhaps a little bit over 6 feet in height. Okay, 5,280 feet. So if you have a pace, or perhaps we could call it a stride. Let's say you're out pacing off a distance, right? Every time your right foot hits the ground, you count a pace. Now, let's say you count out 1,000 of those, and it turns out you measure 1,000 of those paces, and it's 5,280 feet. You see, now you've got a derivative length for the pace of 5.28 feet. And in fact, the word mile actually comes from the same origin as the word mil, which means 1,000, right? So 1,000 paces of 5.28 feet each gives you the mile of 5,280 feet. And it appears as if a submultiple of that unit of measurement, which is still in use today, may have been utilized in the laying out and measuring the dimensions of Stonehenge. Is it possible that our feet and our miles are as old as Stonehenge? That's possibly an implication here. Now, I did say that there was some geometry involved, so let's explore a little bit of it. And we're only going to unpack some of this stuff now. There's way more that we could get into, but for the purposes of keeping this into a manageable chunk of information, we're going to kind of limit ourselves to what we get into. But we've seen that there's an astronomical component, and it starts with something as simple as that one alignment that occurs in the northern hemisphere one time each year on the longest day of the year. And on that morning, the rising of the sun is captured in that alignment of Stonehenge. Okay? Question we'll come back to shortly, directly here, is there more astronomy involved in the layout of Stonehenge? And I think the answer is probably yes. Okay? But first, let's look at some geometry. Okay, so here we have what's called the golden rectangle, or sometimes the rectangle of the whirling squares. Because once you know how to lay out the golden rectangle with those proper, as they have been called, to divine proportions, you can create this logarithmic spiral that looks something like this, that we actually find reproduced in various natural phenomena. So this is the rectangle of the whirling squares, also known as the golden rectangle. It was very important to artists and architects and builders throughout the ages, including, I would suggest, possibly the builders of Stonehenge, because one very prominent place this particular rectangle shows up here, I'm going to flip it up on its vertical axis, and here we have an elevation diagram of the sarsen stone, the horseshoe trilithon, the big rocks in the middle, and here the red border gives you a golden rectangle. It looks like the 5 horseshoe trilithons were quarried and shaped and assembled to reproduce the golden rectangle. Either that or it's just coincidence. And they just luckily hit upon this particular rectangle. The dashed lines here show that you've got a mortise and tenon type construction between the lintels and the uprights. The uprights had a carved knob in the top, and there was a tongue, if you will, and then there was a groove or an indentation in the bottom of the lintel stones so they could fit together. And here we have sort of the summary of what we've seen here, what we've been talking about. Here's your 10.56 feet that forms the distance, the length of the lintels, and it's also the center line, forms the center line of the sarsen stone uprights. So here is our sunrise alignment through the aperture. Now you can just barely make out the heel stone right here. The heel stone marks that position on the horizon. So now, if you are facing east, right here at the alignment, north is going to be to your left, south is going to be to your right. Okay, so what's happening now, this is the longest day of the year. So from now on, the days are going to be getting shorter after this. So each day, the sunrise is going to be shifting away from the north towards the south. And eventually, standing in this same position, the rising of the sun will be blocked by this upright right here. You won't see it. You'll have to wait a whole year for the sun to migrate. Once it gets to winter solstice, turns around, starts coming back. It'll take another 6 months. And then on the morning of the longest day of the year, it's going to rise above the horizon, right along the axis of the structure. Okay. Now, what about other alignments? Well, it's very probable that there are major lunar alignments built in as well. And as it says here from this website, Stonehenge is famous for its alignments with the sun. But did you know that the ancient monument may have also been carefully designed to align with the movements of the moon? 2024 is a special year, and it actually bleeds over into 2025 as well, as an astronomical phenomenon called the major lunar standstill. This rare celestial phenomena presents an opportunity to explore the connection between Stonehenge and the moon. Now, the likely connection is what is called the station stone rectangle. Now, the station stone rectangle is defined right here. If you look at this aerial view, there's a rectangle. There's two stones that still define the rectangle, and there's depressions in the ground that define the positions of the two missing stones. So the rectangle can be recreated pretty accurately. Okay. Now you'll notice that the rectangle looks virtually like it's tangent to the circle upon which the sarsen stone circle is drawn. Okay. Let's see if we can. Yeah, Stonehenge is going to stream the exciting lunar standstill live. Researchers are investigating whether the Neolithic monument is aligned with the moon. Now, I'm going to suggest that if I had to place my bets, I would place it that yes, it's definitely aligned with the moon. Okay. But let's go here to this diagram. This shows the lunar alignments. Now here you see the axial line. Look, midwinter sunset following the blue arrow, and you have midsummer sunrise, the oranger colored arrow. This particular diagram shows us the heel stone, and it also shows us the ditch and bank complex. And this dashed line here is the lunar rectangle. And notice this right here, this line right here, that points to the southernmost moonrise at the major standstill. So it looks like this monument also, like other monuments, memorialized the subtle motions of the moon throughout the course of its 18.6 year cycle. Very much, in fact, like we find at this monument way over in Ohio. This is called Newark. And Newark is laid out according to both sun and moon alignments. Now let's go back to this one. This is showing the major axis of Newark, points to the horizon, points to the position on the horizon where the maximum northern moonrise occurs. Now let's go back to here. And what do you see here? You have the southernmost moonrise. And so this is going to be also a maximum lunar rise. Why were these people over in Ohio building this enormous structure that required an enormous volume of work, a lot of labor to build this huge structure to memorialize the entire cycle of the moon, 18.6 year cycle of the moon. And here you have all of the alignments, all the significant key alignments built into the monument. And if you have the correct perspective, the correct position within the monument, then these alignments these moonrise positions will show up between the gaps, the apertures. You see, look at the octagon here. There are gaps in the octagon. You see that? Knowing where to position yourself, you will then can witness the moon's motions with a high degree of precision. Now, let's go back to the basic concentric circle configuration of Stonehenge here. And let's abstract that by going like this and then this. So here we have just abstracted the red circle representing the center line, of the Sarsenstone circle, and we have the blue ring marking out the center line of the bluestone circle. Now what I'm going to do is I'm going to show you the dimensions here, just as a reminder. Now this is to the center line, not the outer face, because the Sarsen stones are thick, right? So you can measure to the outer face, but you can also measure to the center line, right? If you wanted to have them accurately positioned, you would probably go ahead and put down a couple of different lines in order to have a way of calibrating. But anyways, we can see right at 100.8 feet. Okay, that's for the center line of the outer Stonehenge Sarsenstone circle. And let's see, let's go here first. Okay, so here we have now the center line of let's go back here, of the bluestone. Right here at 79.2 feet. So up here in the right-hand corner, what I've done is I've taken the ratio of the two circles, the red circle, the red ring, and the blue ring. So 100.8 feet, then divided by 79.2 feet gives us the ratio, 1.2727. Now, to show you some of the geometry that's been encoded into this structure, I'm going to show you, first of all, pi with three dots right here represents the 3.141592654, goes on forever and forever. It's an irrational number that never terminates and never repeats. Now, it's been known that amongst different cultures, even right on down to the medieval Freemasons, down to our own time, builders have typically used these two whole numbers, 22 divided by 7, to get a value of pi that's very close to the very refined value. Notice that in the 10th position, it's the same. In the in the hundredths positions, it is the same. And then when you get to the 1000th position, it's off by 1 digit. So it's basically 1/1000th of off in accuracy when you get to the third decimal point, right? So for practical work, 22 over 7 is perfectly acceptable, right? If you're building a structure on the size or scale of Stonehenge or anything else that would be typically room-sized, house-sized, building size, etc. Okay, so now here's where the interesting geometry comes in. You know that if we have this circle here, the blue ring, and it's 79.2 feet, you can see right here that the diameter of that circle is going to be the same as the side of a square enclosing that circle, where the midpoint of each side of the square is precisely tangent to the 4 quarters of the blue ring, right? Now, if I draw that square around it and its side length is 79.2 feet, then its total perimeter is 316.8 feet. If I go over here, remind you, builder's pi, 22 divided by 7. So instead of multiplying 100.8 by the exact value, which you can't get anyway, you have to round it off, but using that times builder's pi, we see that the circumference of the red ring is 316.8 feet. So in other words, look back at this diagram. What we've essentially done here is we've shown that Stonehenge represents the squaring of the circle geometric exercise. Or we have to assume it's just another coincidence. And okay, 1 coincidence, I'll buy it. 2 coincidences, maybe. 3 coincidences. At that point, I think we have to start looking beyond coincidence and look at pattern and intent and not coincidental. But if it's not coincidental, then of course there's meaning implied. Okay? So let's keep moving on here. We've shown now that we've got manifest showing up within the structure, within the design. In the elevation, we find that probably the key elevation of the whole monument is the Sarsen stone ring. I'm sorry, the horseshoe trilithon. They're the biggest most massive of the stones, and they embody the golden rectangle. Now we go over here to the ground plan, and we do see that the two prominent rings, the sarsen stone ring and the bluestone ring, manifest the squaring of the circle. Okay, well, let's keep moving here. If I now add in the Star of David, all right, also known as the Seal of Solomon, we have some interesting geometry that we're not going to explore in this, but we do explore all of these related geometries in my geometry workshops and classes that I do. And at the end of this, I'll talk about one that's coming up very soon at the end of February that's going to be open to the public and in a very special place. And this is sort of some of the kind of stuff we dive into. But so now what I've done here is I put the Seal of Solomon within the blue ring, and it gives us this hexagon in the center of the Seal of Solomon. And the distance from the centers of each edge across gives us a diameter of a circle. And we can just put put the ground plan back in, and you can see how the bluestone horseshoe is defined. Now somehow my red star here has gotten slightly off. It should be a little bit adjusted, but you get the point. The bluestone horseshoe fits right commensurate with the hexagon inside the Star of David. Okay. Now, I am going to jump 2,000, almost 2,500 years into the future, nearby to Glastonbury, and there is a building. There's the ruins of a building on part of the ruins of the Glastonbury Abbey. And this goes back, this is a chapel from the Middle Ages, and it's one of the few things that's mostly intact, remnant from the rest of the monument of Glastonbury, which, if you know any of the legends associated with Glastonbury, you know that it is associated traditionally with the Holy Grail. And there's a whole story about the Holy Grail being hidden at Glastonbury in the very early days of Christianity. In fact, it is said that the first Christian church, according to legend, was a small circular chapel that was built right on the site where St. Mary's Chapel is now built. And for some reason, according to the legend, the original dimensions of that circle were very important. And so they were preserved through several incarnations of a temple being built on that spot. Up to, I think, the building of St. Mary's Chapel, the temples were always circular. With the building of St. Mary's Chapel, the width of the original circular temple was incorporated into the width of St. Mary's Chapel. And if we look at the ground plan here of St. Mary's Chapel, let's go back. You can see the doorway here, right, would be this opening right here. And it's 68.4 feet on the long axis, 39.6 feet on the short axis, which, if you're at home and you're so inclined, grab a calculator or do it longhand, divide 68.4 by 39.6, and what you end up with is the discovery that this is a rectangle that is called the root 3 rectangle. And this particular rectangle has a very easy, very logical way of being derived simply and naturally from some of the most fundamental geometric exercises that you can perform. And let's take a look here. We go back to Stonehenge, the plan with St. Mary's Chapel, Stonehenge with the Star of David in there. And what I'm going to do now is I'm going to juxtapose the ground plan of St. Mary's Chapel at the same scale directly onto this diagram of Stonehenge. And what we discover is very interesting. that particular rectangle is exactly the rectangle, produced by the 4 of the points of the Star of David or Seal of Solomon. Here's the same rectangle right here. See it? And same rectangle right here. Now, do we call that a coincidence? Well, obviously it has to be a coincidence, right? Because we assume that there's no connection between the builders of St. Mary's Chapel in the 1100s, I'm pretty sure it was in the 1100s or early 1200s, and the ground plan of Stonehenge, right? So clearly all these things are coincidences. There can't be any meaning to this or significance. Really? Anyways, maybe. At some point, though, we've got to go beyond coincidence. I would like to mention that one of our original sponsors at Cosmographia, CBD from the Gods, is following us here to our new podcast, Squaring the Circle. As many of you know, I've been using their products for going on 4 years now, and having tried a number of CBD brands, CBD from the Gods seems the most effective for my needs, which is primarily as a sleep aid and as a remedy for inflammation and associated pain. I use both the oil and the salve. My wife also likes their products, especially the salve, which alleviates the pain in her hands, which is the result of working for years as an electrician. If you've been thinking about trying a CBD product and experiencing the benefits for yourself, give CBD from the Gods a try. To learn more and see their product line, check out cbdfromthegods.com. Any purchase of their products helps our efforts here at Squaring the Circle to realize our goal of making this world a better place. Thanks. Now, let's get to some updating here, some news that has come out, some of the most recent research onto Stonehenge. In the August 15th, 2024 issue of the prestigious British science journal Nature, an article was presented, and the title of this article was this: A Scottish Provenance for the Altar Stone of Stonehenge. Scottish provenance, right? So the article opens by saying Stonehenge, the Neolithic standing stone circle located on the Salisbury Plain in Wiltshire, England, offers valuable insight into prehistoric Britain. Construction at Stonehenge began as early as 3000 BC, that's 5,000 years ago, with subsequent modifications during the following 2 millennia. Okay? The megaliths of Stonehenge are divided into 2 major categories: sarsen stones and blue stones. The larger sarsens comprise duracrust silcrete, predominantly sourced from the West Woods, Marlborough, approximately 25 kilometers. Okay, so, yeah, little bit, I think I said 25 miles, so this would be less. 25 kilometers would be, a little bit, probably around 15 miles, 16 miles, somewhere in there. Okay, and the blue stones, the generic term for rocks considered exotic to the local area, includes volcanic tuff, rhyolite. I think rhyolite and dolerite are the dominant rock types in there, and sandstone. So there's some sandstone mixed in with it. Some lithologies are linked with Neolithic quarrying sites in the Preseli area of West Wales. So that's where they would have come from. An unnamed Lower Paleozoic sandstone associated with Wales, West Wales area on the basis of fossils is widely disseminated as debitage, which is the flakes and the wastage left over from quarrying and from shaping stones, flint knapping, and so on. So it's widely disseminated at Stonehenge. But now here's where we get to an anomaly. The central megalith of Stonehenge, the altar stone, is the largest of the blue stones. And it's the largest of the blue stones measures 4.9 times 1.0 times 0.5 meters. Okay, so what does that work out to be? Let's see here. I think I've worked that out a little bit. It's easy enough to do. So it works out to be, I'll just grab my calculator here. So 4.9 meters would be 4.9 times. So that's 16 feet. So it's 16 feet long. It's 1 meter wide. So it's about 4 feet, a little over 3 feet wide, and then half a meter thick. So it's about a little bit more than 1.5 feet thick. So if you can picture that, okay? So what they realized was that the altar stone didn't match the type of stones that were quarried in Wales that were then utilized as the blue stones. So where did it come from? That becomes the mystery. What they realized was that they took the rock database. There's a rock database that exists that's been compiled for decades and decades. And what it does is if you've got a rock and you're trying to figure out where it came from, this database is derived from the study of geological strata from all over the planet. It's particularly profuse, let's say in Europe and the British Isles, North America, right, where most of the rock types that are accessible to the surface have been mapped. Okay, so by accessing this database, there was a group of scientists led by Anthony J. Clark, was his name, and he worked with 5 others. And he was an expert in mineralogy, right? He was actually a graduate student when he was doing this work. So what he did was he procured some samples that had fallen on the ground, that had come loose from the recumbent altar stone at the site. So he got these flakes and he was able to match them to the database. So here we have a map of the British Isles, and you see down here very prominently displayed is Stonehenge. Where did the altar stone come from? It came from all the way up here. There's the same type of rock here, crops out at the very northern tip of Scotland. It actually also shows up on the Orkney Islands here. Well, depending on where it sourced, here or even up in the Orkneys, turns out this is a long way. It varies 460 miles or more, depending. If it came from the Orkneys, it was more. It's getting closer to 500 miles. Okay, so that's a long way. Now, the weight of this was 6 tons. Okay, that's 12,000 pounds. That's a big old heavy stone to transport. So what's the problem here? Obviously, some method of transport had to be utilized to get that stone 460 plus miles from the northern tip of Scotland down to the building site at Stonehenge, right? So in this article, which appeared in Nature, it's entitled A Scottish Provenance, the Altar Stone of Stonehenge. Now I'm going to quote from the article. We posit that the altar stone was anthropogenically transported to Stonehenge from northeast Scotland, consistent with evidence of Neolithic inhabitation in the region, whereas the igneous blue stones were brought around 225 kilometers or 140 miles. A Scottish province for the altar stone demands a transport distance of at least 466 miles. Nonetheless, even with assistance from beasts of burden, rivers, and topographical barriers, including the Grampians, southern uplands, and the Pennines, all mountain ranges, along with the heavily forested landscape of prehistoric Britain, would have posed formidable obstacles for overland megalith transportation. Yes, it would have. Now, when this news broke in August, BBC did some extensive, the British Broadcasting Corporation did some extensive coverage of this story here. And this is in one of the reports, they state the obvious when they say the discovery shows the construction of Stonehenge was a far greater collaborative effort than scientists realized. It also means that the ancient monument near Salisbury in southwest England was built with stones from all parts of Great Britain. Now, here's quoting a Professor Pierce, who was one of the people involved in the study. It blew our socks off when we discovered it was from northeast Scotland. Yeah, okay, yeah. It was a shock, to say the least. Coming from that distance, more than 700 kilometers, was remarkable. The Neolithic people must have been pretty well connected, far more connected than people give them credit for. They must have been well organized. Stonehenge seems to be this great British endeavor involving all the different people from all over the island. So another participant in the altar stone study was a Dr. Robert Eicher, I'm not sure how to pronounce it, it's spelled I-X-E-R. He was from the University College in London. He is quoted by the BBC as saying this: the work prompts two important questions. One, how is the altar stone transported from the very north of Scotland, a distance of more than 700 kilometers, to Stonehenge? And more intriguing, why? There are obvious physical barriers to transporting by land, and an equally daunting journey if going by sea. These findings will have huge ramifications for understanding communities in Neolithic times, their levels of connectivity, and their transport systems. Yes, indeed, their transport systems. Now, I would like to know what kind of seafaring vessel was capable of carrying this 12-ton stone through the stormy North Seas if you're going to go around the island all the way and then land somewhere down near Stonehenge and then offload the 12-ton boulder and then transport it overland to the position of Stonehenge. I want to know what kind of a sailing vessel were they incorporating where it would not become destabilized by carrying a load this heavy. But I've not yet been able to find any specific information. In fact, I think that the question is wide open, as Dr. Eicher says, it raises questions about their transport systems. One of the senior curators working for English Heritage, and they oversee and manage the Stonehenge site, Heather Sebeyer, I hope I'm pronouncing her name correct, she was compelled to make this comment. It is phenomenal. It is phenomenal that the people of the time brought such a large stone all this way. They must have had a compelling reason to do it. In an interview with phys.org, Sebeyer speculates that Stonehenge isn't a settlement site, but it's a place of ceremony or ritual. Oh, okay. Well, then here's what I have to wonder about. First of all, I'll say yes, go to all that effort to transport these stones And look, hey, even from 17 or 20 miles away, transporting the sarsen stones for the outer ring and for the horseshoe trilithon, that's going to be a major effort. Now, 140 miles transporting all of the bluestones, that itself is no minor effort in its own right. So obviously a great deal of effort. They didn't choose the site of Stonehenge based on, oh, here's a convenient source of rock right here at the site that we'll dig up and use to build this monument. No, they went to great lengths to import stone from 3 different areas, right? So she says they must have had a compelling reason to do it. Yes, they must have had a compelling reason for doing so. And I would also ask, what's the nature? Makes reference to a ceremony or a ritual. So now I'm curious as to what is the nature of this ceremony or ritual that is being conducted at this site that I think we can now safely speculate incorporates astronomy, it incorporates geometry, and obviously I think it implies that there were major concerns about where it's going to be placed, right? Because they obviously, hey, if you wanted to have maximum convenience, like using the sarsen stones, why didn't you shift the whole monument 20 miles away to the source of the quarry from which the sarsen stones were removed? Why do you trudge all the way up 140 miles away to Wales to get the bluestones? Let's consider the dating of Stonehenge. It's placed at between 4,500 and 5,000 years ago. Okay, the period of time called the Neolithic, the New Stone Age. So there's implications to that name. The Stone Age, right? So what's implied almost in that name is that we're pretty primitive in terms of our knowledge of any matters of science or technology and so on, right? The Stone Age, right? People are still living in the Stone Age. When did we come out of the Neolithic? Well, it was with the rise of writing, primarily in Sumeria and Egypt. So typically, writing is dated both in Egypt and to Sumeria somewhere around 2,600 to 2,700 years ago. I'm sorry, BC, which places it 4,600 to 4,700 years ago. Now, the major campaign of construction on Stonehenge is estimated to have been between 4,500 and 5,000 years ago. So basically, what we're learning there is that while writing was being invented in the Middle East and around the Mediterranean, well, at the same time, we have the major building campaign constructing Stonehenge. Coincidence in timing? Well, again, for the sake of argument, let's just say coincidence, that there's no relation between these two very culturally significant phenomena occurring simultaneously, okay? Now, so going back to our study, the Scottish provenance for the altar stone of Stonehenge, lead author Anthony Clark, he was with the Timescales of Mineral Systems Group, Earth and Planetary Sciences in Australia, okay? And he was working with a team, 5 Earth scientists and archaeologists. Now, I mentioned it, Clark himself is Welsh, so he kind of, had an incentive to want to find that the altar stone came from Wales. Here's what they found. They referred back to earlier work that occurred in 2023 on the altar stone, and it was this work in 2023 that called into question these assumptions about the origin and the province of the altar stone. Date for the construction of Stonehenge is 3000 BC. From Clark and others, we learned that constraining the provenance of the altar stone could give insights into the connectivity of Neolithic people who left no written record. when the altar stone arrived at Stonehenge is uncertain. However, it may have been placed within the central trilithon horseshoe during the second construction phase around 2600 to 2500 BC. Okay. We get then they comment this about the altar stone. The central megalith of Stonehenge, the altar stone, is the largest of the blue stones, measuring 4.9 by 1.0 by 0.5 meters, or 16 feet by 3.3 feet by 1.64 feet, is a recumbent stone, meaning it's laying over, and it weighs 6 tons, or roughly 12,000 pounds. And now here's the interesting part. It's composed of a pale green micaceous sandstone with distinctive mineralogy. Two things to note here. Size of the stone at 6 tons, more than 12,000 pounds, but even as importantly, the distinctive mineralogy. Till very recently, as mentioned, it was assumed that the altar stone came from Wales, part of the lithology known as the Old Red Sandstone. But this work that was published in October of 2023 by a group of scientists, they concluded that it was not from Wales. So then where did it come from? That's what led to this new study that was published in August. So this interesting archaeological development from 2024 with regards to Stonehenge is prompting a reconsideration of prehistory in the British Isles. And this has resulted in a determination of the provenance or place of origin of the stones, the type of stone used for the so-called altar stone at Stonehenge, just to recap where we're at with this thing. Since history is usually assumed to have begun with the invention of writing in Egypt and Sumeria, typically dated to around 2600 to 2700 BC, anything earlier than that would be considered prehistory. Okay, so we're now with the first stages of Stonehenge. We're back in prehistory. We're back in the Neolithic or the New Stone Age. So let that image get in your mind. The Stone Age. We're talking about, even though it's the New Stone Age, we're talking about a Stone Age, right? Which carries the implications that we're dealing with primitive cultures. Okay, so now the invention of writing, 2600 to 2700 BC in Egypt and Sumeria. The main building campaign of Stonehenge is going on at the same period of time. These two things are happening simultaneously. Is there any connection? I'm not going to say that there is. I'm just noting that temporally they are happening concurrently. The date, the century or two to which we give the origins of writing coincides precisely with the major building campaign of Stonehenge. These two things are happening simultaneously, okay? So in this study, the lead author and leader of the investigating team was Anthony Clark. He was with the Timescales of Mineral Systems group with the School of Earth and Planetary Sciences in Australia. And he was working with a team of 5 others, a combination of earth scientists and archaeologists. Clark himself is Welsh, so he may have a preferred outcome of this to show that the altar stone did in fact come from Wales. Authors begin their report by saying that that Stonehenge, or the Neolithic standing stone circle located on the Salisbury Plain in Wiltshire, England, offers valuable insight into prehistoric Britain. Construction at Stonehenge began as early as 3000 BC, with subsequent modifications during the following 2 millennia. The megaliths of Stonehenge are divided into 2 major categories: the Sarsen stones and the blue stones, as we talked about. The larger Sarsens comprise what's called a duricrust silcrete, predominantly sourced from Marlborough, which is approximately 25 kilometers north of Stonehenge, maybe roughly 14 or 15 miles north. So that's still a long way, because these stones are huge and they weighed many tons. So there was earlier work that was completed in 2023 that first called into question, however, the origin of the altar stone. So if the altar stone was not part of the type of stone, the lithology that came from Wales, and it was not part of the which was where it was previously believed to have come from, what kind of stone was it and where did it come from? So it was in this earlier work that was published in October of 2023 that determined it was not a part of the same stone from Wales. Now, when did the altar stone itself arrive? It's not really known for sure. It was probably during that first 500 years of the building campaign. So here's what the Clark and his colleagues had to say in their paper about the altar stone. The central megalith of Stonehenge, the altar stone, is the largest of the blue stones, and it measures in meters 4.9 by 1.0 by 0.5 meters. Well, that works out to be about 16 feet long, 3 1/3 feet wide, and 1.64 feet thick. Okay? It weighs about 12 tons. It is of as they describe it, a pale green micaceous sandstone with a distinctive mineralogy. Distinctive mineralogy. So that should cause your ears to perk up right there. It has a distinctive mineralogy. I wonder what's distinctive about this mineralogy. So, first thing, keep in your mind the size and mass of this stone and the weight. Okay. The second thing to keep in mind, the distinctive mineralogy. What about this distinctive mineralogy? Well, in the BBC report that I referred to earlier, it describes first the protocol and then the results. So these earlier scientists from 2023 compared the analysis of the altar stone with 58 samples of old red sandstone from across Wales and the Welsh borders, and then they found that the altar stone's composition could not be matched with any of them, right? But here's the interesting point in the BBC report. According to the researchers, the altar stone contains a lot of barium, a kind of metal. The university said this was unusual, and it could help reveal its source. Well, because of the unusual metallic composition of this rock, it did indeed lead to assist in finding its source. So the Clark team used what's called the very comprehensive Global Rock Fingerprint Database. Turned out that the closest match to the petrology of the altar stone was with rocks located in the Orcadian Basin in northeastern Scotland. This raises some interesting questions, to say the least. And they go on to say, the authors say, we posit that the altar stone was anthropogenically transported to Stonehenge from northeast Scotland, consistent with evidence of Neolithic inhabitation in the region. One of the senior curators working for the English Heritage, which oversees and monitors Stonehenge, Heather Sabire, was compelled to comment this, quote, "It is phenomenal that the people of the time brought such a large stone all this way. They must have had a compelling reason to do it." In an interview with phys.org, Sabire speculates that Stonehenge isn't a settlement site, but a place of ceremony or ritual. Yes, I would agree. They must have had a compelling reason for doing this. And we might ask, what is the nature of a ceremony or ritual that requires a 6-ton stone being hauled over 460 miles? To simplify it, say it had a ritualistic or ceremonial function, that tells us nothing. I'd submit that it was the unique mineralogical properties that compelled these megalithic builders to undertake such a daunting task, whether by land or by sea. But this opens a can of worms most archaeologists are loath to acknowledge. It has been demonstrated convincingly that these builders were also astronomers. It's also obvious that they were very proficient engineers, obviously, to be able to cut and quarry and transport these stones and erect these stones. Yes, they had to have been highly accomplished engineers. Also, can make a very strong case, way beyond what I just presented tonight, that these people were geometricians as well. They had a very strong working knowledge of geometry. Okay. Now, is it possible that we can add to that list of attributes that they were mineralogists as well, or geologists, and that in addition to the geometry of the site, the orientation of the site, the astronomical orientation of site, the engineering capabilities of these people, are we now adding to that list a geological component to this mystery? And why are all of these elements confluing in this one particular structure? I think this is a question that needs to be asked. But like I just said, this opens up a can of worms that it seems like a lot of archaeologists are loath to acknowledge. So the fact that they were astronomers and engineers and geometricians, probably geographers as well, and now possibly mineralogists or geologists, I would say this is some relatively serious conjecture that we have to consider around these questions that are being raised. Who are these people? What was their motive? This conjecture that's implied here carries some seriously thought-provoking implications. Perhaps the takeaway here is that it's time to expand our thinking and realize that the ancient ritualistic functions of these forgotten people were not predicated upon superstitious and groundless beliefs, that they were not just relegated to the category of barbarians, Stone Age barbarians, but that this structure evinces a design that has a scientific rationale to it. So this leads us to a conjecture I've been proposing for decades. The sacred structures found all over the world, all over the ancient world, whether temples, pyramids, earthworks, megalithic structures, cathedrals, etc., exhibit such striking parallels in design and function, reaching across time and space, that I think we are justified in speculating that these may have been components of an archaic technology, a technology that has been lost for centuries, if not for millennia, and now perhaps is on the verge of being rediscovered. Thank you for joining me tonight on this episode of Squaring the Circle, and I will see you next time. I'm Randall Carlson, over and out.